Okay, now I will explain the false position method implementation using MATLAB code. First, I define the function x cube minus 2x square minus 5. After that, the user is promoted to input the lower bound x lower and the upper bound x upper, and the minimum error also the maximum iteration. Okay, after that the variables iter and errors is initialized. The iter is iteration counter and errors is to store the errors for each iteration. Okay. And here is a practicing check. Practicing check. It checks if the initial point x lower and x upper brackets bracket the root. If not, it throws an error. So if x lower multiplied to x upper is greater than or equal to 0, through an error, which it is says the initial points do not bracket the root, and in this loop. After that, iterate until convergence or max iterations reached. Here, so after that, calculate the next approximation using false position method, which its formula is x lower multiplied to function of x upper minus x upper multiplied to function of x lower, all divided to f of x upper minus f of x lower. Okay, now here calculating the error, which it is x of next iteration minus x of lower iteration, and then in this line it stores the error in errors array, and last it prints the iteration and x next, and x next is current approximation, of course, and error. That's it. And after that, it checks if error is less than minimum error, then break and end. So it checks if the error falls below the minimum error. If yes, it breaks out of the loop. Okay. Now for bound update, it updates the bound x lower. It updates. Sorry. Okay. Space. So here it updates the bounds x lower and x upper based on whether the function changes the sign between x next and x lower. And here we plotting the function. It plots the function, the estimated root and the root against iteration. So here the graph, we draw the graphs, x values, y values, and plot. Line width is 1.5, and this function, actually I try to explain it. It is when I click on any point, it disappears when I click to another point. This function does this in a graph. It's a special function for graphs. And here is same like in the Newton-Raphel method code I use it. It's use this arrow to draw a circle, a red circle. The marker size is 10, and that's it. All is same, so I don't lose many time. That's it, and thank you. And of course I will run the code to try it. Now the lower bound, let's say -2, the upper bound, let it be 4 or maybe 3. The minimum error is 1e minus 3, for example. The maximum number of iteration is 3. Okay, this is the values. X is like this, and blah blah, and these are the graphs, the false position method graph, and the error against iteration graph. That's it, and thank you.